So in preparation for learning outcome 2 of Unit 8, the electrical system, we need to have a look and get a basic understanding of wire and how we're going to connect it to make up a circuit, which is the project that you're going to be doing. So I've actually assembled 3 different types of wire here, and each wire, although this one you can actually see is red, black wire, also black wire. Each one of these is actually different in terms of its thickness and its ability to handle current. Remember, current is measured in amps, and amps is our flow of electricity. So, first thing first, if we have a look at each one of these, we can actually see that these wires are actually rated differently in each case. The red wire actually has 28/0.30 millimeters on it. This black wire, 9/0.30 millimeters on it. And this wire, the other black wire, 14/0.03 millimeters. What I want to do is I want to have a quick look and see what that actually means to start off with. And that way you'll have a better appreciation of what we actually need to know about this and what it means in terms of making your circuit. So the first thing I'm going to do is I'm going to take this tool here, some of these wire cutters here. They've also got a wire stripper on the end, and I'm going to use this wire stripper section to strip a section of the insulation off of this black wire as a starting point. Now the important thing with this is I want to make sure that I actually don't cut it into the wire itself. I want to just cut through the insulation. So I'm starting off slightly large, and then I'm going to just go down one more size, and there I can actually see that I've actually broken off the insulation, stripped away the insulation without actually breaking off any of the wires underneath. I'm just going to do that, get a little bit more using the same size. Just bring that through. And the reason I want to do that is so I can spread these wires out. And what we'll see is if I spread these out and you have a close look at that, then you'll see that in fact just about there, a little bit more. So we've spread them out enough. If I hold that over the black, you should be able to see that there are in fact 9 strands of copper wire, this being stranded wire. Now unlike household wire, we always use stranded wire in automotive use because we need the flexibility, because if it's going to the engine block as an example, there's going to be some flex there, and a solid wire as we have with household would actually split and eventually break. So we always use stranded wire, and in this particular case, as it says on here, we've got 9/0.3 millimeter strands, so 9 strands of 0.3 millimeter each strand, being 0.3 millimeter in diameter. The other thing we need to bear in mind is that sometimes wires are actually rated, as you can see here, in AWG for their actual thickness, American wire gauge. Sometimes they're rated in the way that you can see on these Durite cables, and sometimes they're rated by amperage. And really speaking, the one that we're interested in is the amperage rating for it. So one of the pieces of information you're going to need to do this is a chart showing you the actual size of the wire and the current carrying capacity of that, which I'm going to put up on the screen now. So from this you can actually look up and see what the 9 strands of 0.3 millimeter wire, what its current carrying capacity is over a reasonable length that you'd actually be able to make a circuit with. Next thing we need to have a look at is the fact that if we take the two extremes here, I've got the 9 strand there by 0.3, and if I take the heavier red wire here, and again I'm going to do exactly the same, just going to strip that back a bit. I don't want to be cutting through the actual copper core, I just want to cut the insulation. And we can see there's quite a dramatic difference in the actual thickness. Let me just twist that around, just get those strands all back together. And you can see there's quite a dramatic difference in the actual thickness of those two cables. Now this has got an impact when we actually go to connect our cables, because we need to select the correct size. And I'm just going to cut a little bit off the end of this one. Just cut these strands off here using the wire cutters. Now, standard automotive connectors come in 3 different colours. They come in red, blue, or yellow. And it's important when we actually look at the different connector sizes that we make sure that we use the smallest connector that will fit the wire gauge that we're actually using at that time. So if I take our thin wire as an example again, the yellow connector, which is the biggest we've got, yellow crimps connector, can go on there, no problem at all. But it's a very loose fit, and it's not going to give a good, strong, firm connection. Blue connector is the next size down. And again, that's quite loose. So for this size wire, I'd be using a red connector. And that should be a nice snug fit, which means we can have a good, long-lasting electrical connection. Now these particular connectors are designed to actually fit, or connect, I should say, 2 wires together. So again, if I strip that down, strip the insulation off, and I always like to give them a little bit of a twist at the end, just to prevent them fraying as they go in. I can put that into there, that one into that one, to connect 2 wires together. If a wire's too short, if a wire's been broken, or something like that. Now there is a problem with this. This is great if it's on the inside of a car. However, if it's exposed to moisture, those ends are not sealed. That can mean that water will get in, start to corrode the connection, give us a high resistance, and potentially give us an electrical fault. So the practical alternative to using one of these crimped connectors is use this type. Now the reason we don't use this type all the time is because they're a lot more expensive. But this type is actually lined with an adhesive, and after we crimp the connector onto the wire, so our wire would go in just the same, we crimp the connector onto the wire, we'd then use a hot air gun which would actually melt this, the glue inside I should say, and cause the outer sheath to shrink down in size and actually settle, or cause the glue to actually settle between the actual outer sheath and the wire itself, giving us a watertight seal, which would be good even if it's on the outside of a car, giving us full free connection that's going to last for years. And there are a number of different types of connector. We could have a bullet connector like this. This is the female, that's the male end there, and these two would allow us to connect and disconnect a wire several times. We also have a spade connection, which there's a very small spade connection in there, a larger male one just there. We also have different size eyelets, which would be good if we're using or we're trying to connect a wire to an earth, or perhaps a bolt-on connection, and this would have either a screw going through to the bodywork or a screw attaching it to another component. Now, although I've actually only shown you the reds here, we get just the same type of variety in both blue and also in yellow connectors. And this allows us to connect onto other components when we've got a heavier connection. We might need a blue connector to go onto the switch. So that would then connect onto there with the wire crimped on just the same, giving us a good steady connection that we can make and break as we need. So in terms of making a crimped connection, we saw before how we used the wire strippers to remove the insulated section. We then put our crimped connection over the end. And I've stripped off slightly too much. You can actually see I've got a little bit of wire poking out just at the end here. And so I'm going to just trim the end of that ever so slightly. Now in this particular instance it won't matter because as it's going through there it's not going anywhere. And I'm going to leave a small amount sticking out just to help the actual strength of the crimp. I'm then going to use ratcheting crimping pliers, which we can see have red, blue and yellow sections on them, depending on which size crimp you're using. In this case I want the red. So I'm going to set the actual crimped connector, that ring terminal, in there like that. And yes, I'm fully aware I haven't got the wire in there just yet, and that's the reason because I actually want to get this set up first. So I've put a little bit of tension on there to hold it, and I want to make sure that the actual eyelet is nice and square, so the crimp is going to be in line with the eyelet. It's going to give us a really nice, neat job. Then carefully, I'm going to put the wire into the crimped connection, making sure it is coming through on the other side, just here, and then applying pressure to the pliers, I can crimp that together. Now the pliers are locked on there now, that's quite firm, but it hasn't reached the correct tension for this connection, so I'm going to continue squeezing until it releases. Give me a good strong crimped connection with no bare wire on the back that could short out and cause a problem. So that's one way we can use to connect a wire, and that's pretty strong. Now an alternative way of joining two pieces of wire together is using a method that I call twisting, which we're going to demonstrate here. And I've got a couple of pieces of wire, and you can see that I've actually stripped more off than I would for a crimped connection. And the next step is going to be, I'm going to fan these out. I want them separated completely. So I'm separating them out as far as they will go. Do the same with this one. And this method has been proven in the workshop. I've actually done a tug test on by connecting the wire to a vise and just pulling on it until it broke. And this actually allowed the main wire broke before the actual connection did. So it really does give you a strong connection, but there are a couple of disadvantages with it, which we'll talk about as we go through. But the procedure, after we've got them fanned down like that, we're going to actually put them together across each other so the wires are actually interlinked. And then I want to bring them nice and close. I'm going to twist that wire around. Nice tight twist. I'm going to do the same to the other one. Again, nice and tight. So we end up with that shape there. What I'm then going to do is get the wires and give them a bit of a tug apart. And what I'm doing there is really tightening up on those twists. Followed by, so when I've got that little bit extra there, I'm then going to twist this around nice and tight. I want it to be nice and tight on the actual main wire coming out. And I'm just about to the end there, so I'm going to cut off the excess using the wire cutters. Let's get rid of those ends. Just finish that off. And do the same with the other side. I want that to be really in there, nice and tight. Oops. Get it really on. And what we're trying to do is make sure that the sharp cut end isn't sticking through, and I'll explain why in just a minute. And that gives us really good, strong connection that will last a long, long time, except for a couple of problems. The first one being, it takes quite a bit of time and a little bit of practice to actually get used to doing. The other thing is, that's not insulated. So this means we've actually got a bare wire somewhere in our harness. And we can't have that. We need to make sure it's insulated so it can't cause an electrical fault elsewhere. So we're going to have to do something about it. Now, a lot of people will actually say use solder after you've actually got to that point, and use a soldering iron that causes this metal. It's a low temperature melting metal, and we would melt it into there. But personally, for this type of connection, I don't like doing that. And the reason I don't like doing that is because the solder makes the wire brittle, and it's more likely to break and more likely to give you a problem later on. So my advice would be to actually use a product like this, which is heat shrink. And again, this comes in a couple of different types. I want to be about the same amount over each, so I'm going to cut that down like that, and that would simply slide over there. And again, this has got an adhesive lining inside it. Not all heat shrink does, mind, but this particular one has got an adhesive lining inside, and when we heat this up, as the name suggests, it's going to shrink down, it's going to recover its original size, it's going to then insulate and glue itself to that, giving us a good watertight flexible seal. The other advantage of this method is we could use it. Imagine we need to break out two wires. We've got one larger wire coming in, and we need to break out two smaller wires. So here I've actually chosen the 14 by 0.3 as opposed to the 9 by 0.3 here. So this has got 14 strands, each of these got 9. These are capable of carrying a little bit more current together. However, this 9 is the smallest that's readily commercially available in the island. And the procedure for this is pretty much the same. But this time what we're going to do is lie these two together and mesh it with this one. So I'm just going to spread that out. Okay. Okay. So what we've got, I'm going to put our two smaller wires together, like so, 2 9 strands. And then our 14 strand is going to go through in exactly the same way. We're going to twist it. The tighter that twist is, the better. But I'm only doing it by hand, I'm not using pliers or anything. Nothing flash. So that's like that. Again, pull them apart. That's really going to tighten up that twisting. Make sure it doesn't come undone. And then we're going to wind the wires on. And again, I'm going to cut them down to a suitable size so I haven't got any unsightly ends. all nice and tight, all nicely tidied up. And again, we've got a nice strong connection that's also flexible. And to insulate it, same again. Now the only drawback here is down the center there will still be a small gap, so this is not as watertight as the previous connection down this end. However, from experience, it still gives you a good long-lasting joint if that's actually heated up and recovered onto there. Now, the reason I'm showing you this is because on one of the circuits you're going to make, you're making a parallel circuit where you're going to need to have a feed coming in from a switch and breaking out and going to two different light units. You're then going to have it coming back in from the two different light units back to a single wire to go to the earth. So just a quick look at the two circuits that you're going to be making. You've got two there, both using two light units. You're going to be making a series circuit and you're going to be making a parallel circuit, and then you're going to be testing those. So the actual connection of those is going to be pretty straightforward. You're going to have, as I said, two lamp units. You're going to have a fuse holder, and you're going to have a switch to use. The connection is going to go from the actual fuse. It's then going to go through the switch, then from the switch to our first light, from our first light through to our second light, from our second light down to earth, and that is going to be your series circuit. And this is an image of the actual circuit as opposed to just the components, and you can see where you're going to test that circuit for voltage. The second circuit you're going to make is the parallel circuit. We're still using the same components, but this time the connection is slightly different. So this time, and this is where the Y junction that we made before will come in handy. You're going to need two of these, because when it comes off of the switch, we're going to need to go through to one, through to the other. Oops. So from the switch, the power will then be split to go in turn to each of our lights, and again on the return it's going to come back from each of our lights back to the earth itself, like so. And again on the diagram here you can actually see how you're going to test it, or the various points that you're going to test it after you've made the circuit. Now in both cases you're going to need to use the power equation to figure out what current is going to be flowing through the circuit, and you are going to be actually removing the fuse from the fuse holder. There actually isn't a fuse here at the moment. You're going to remove the fuse from the fuse holder and you replace that with an ammeter to actually check the current flow through the circuit and see how that compares with your calculations. Okay, I hope that's been useful. Please do make sure you watch this a couple of times to make sure you're completely familiar with the different techniques. And good luck.